In this lecture, we'll continue our consideration of some of the root causes of environmental problems by looking at the consumption of the resources we take for granted in everyday life. Just the fact that you're taking this course online, you're interacting with quite a bit of technology potentially, both here from the source, my end, and also from the computer you're looking at, and all the transmission systems and network interfacing. So we consume an increasingly complex array of resources, both in terms of earth resources, the materials we use for energy, which we'll follow up on in more detail later in the course, earth, rock, and mineral resources, electronic consumer goods, consumer everyday products like paper that come from renewable sources but still constitute a heavy impact on some areas to produce the wood and fiber needed, and then building materials, plastics, wood products, all the things we use in everyday life. If you look at the trend of our use of resources over the last century, you'll notice that the growth of resource use has been rather dramatic, and it picked up substantially during and following World War II. And then following the economic boom of post-war America and the rest of the world, we see almost all categories of resources in increasing use. Construction materials come and go, like many of the resources, with the economy. When the economy is down, there's less building, less consumption of resources, but when there's a recovery, then the growth of utilization and demand picks right back up. The growth of cities and the expansion of highway infrastructure and the expanded use of automobiles during the middle and latter parts of the 20th century were a major driver of our consumption of construction materials, both for urban infrastructure, but also roads and other applications. If you contrast the current day and age back with the turn of the last century in 1900, it's interesting to note that about 40% of the materials we consumed were from renewable sources, and wood construction was probably the most typical major construction component. Since then, composites, metal, other asphalt shingle materials, and a lot of other non-wood products have come in increasingly heavy use. By 1995, only about 8% of the materials consumed were considered renewable. We'll look at this chart in some more detail in the following slides. When you consider, if we would take out that aggregate road building, concrete type of materials out of it and look at the other categories, such as minerals, metals, plastics, organics, wood products, and so on, you see a similar trend in increasing consumption over that time frame. And this is driven in part by industrial minerals, and one you might not think of, but was a significant part of our resource consumption, is gypsum materials that are used in wallboard in most modern house construction, and plastics especially, since World War II, have increased their application and variety of uses dramatically since then. You see on the graph at the bottom, the change in the wood consumption is due to the fact that the way that reporting and data acquisition for paper and wood products changed in terms of accounting for paper separate from wood products, whereas prior to that they were lumped together by the agencies that track their use. When you compare the United States to the world, our use has grown slowly but steadily, along with our population increase and our increasing level of affluence as far as our ability to consume more goods. We're a bit more efficient in many of the things we do, and so maybe don't use quite as much per capita compared to the growth of the rest of the world, but that's mainly due to our slower population growth. The world consumption, though, is increasing at a more steady rate, and our global impact on the planet and its resources has increased accordingly. Let's pause and suggest a couple of review questions that you should write down and consider. First, you should be able to describe the trend of resource consumption And what are some of the factors that have affected that trend? Why has there been growth, and why has there been interruptions in that growth? Since World War II, what material resources have been consumed at the greatest mass and rate? Should know the general category. I'm not so concerned that you know the exact percentages. Those you can look up if you need to. And how does the U.S. compare with the rest of the world in its consumption of resources? And what accounts for the rate of our consumption? So make a note of these, and as a review for quizzes, the exam, try to make a list of these that you can refer to. Another aspect of considering material consumption is the notion of weight versus volume. These are both important from the standpoint of the way we manage materials, we price materials, and especially when we talk later in the class about waste products and waste management, volume plays a factor as well in terms of just our ability to store and dispose of waste materials. If you look at the trends over that time in metric tons versus cubic meters, they do tend to track somewhat in that there's been a steady growth in some categories such as wood and paper. When you look at the volume, though, of some areas, you'll find that some of the volumes have not increased as dramatically, but others have. The big change has been the fact that there's been increased use of metal recycling and paper. The metal recycling probably started earlier, and that was driven by economics, the availability of raw material minerals, as opposed to scrap yards, and metal recycling early on became more profitable compared to extraction of new materials. Paper, likewise, there's been a consumer demand and awareness of the impact of forest practices, and consumer shift in appreciation for the need to manage our forests more wisely spurred greater demand for recycled paper products, and thus you see a stronger growth in that category. But another troubling, in some ways, trend has been that the amount of plastic consumed has increased, and the consumption is still greater for plastic on a weight basis, certainly, than recycled paper. Plastic is comprised of petrochemicals, largely oil, and it finds its way into more and more products, water bottles, drinking water bottles, things like that. And again, those lead back into waste issues that we'll address later in the class. If you look at our use per person, and this is where you can think about your own use of resources as being a quote average person, the use per person per year is tied very heavily to the economy. When the economy is up, the use of wood and paper will increase. When the economy goes into recession or economic downturns, then that consumption will be reduced. Our use of metals has stabilized for the most part, whereas we use probably more things made out of plastic, and you probably have commented on this or have heard it commented on, that plastic has replaced the role of metal in many areas, and thus our demand for metal products has not continued to increase the same way that plastic has. Plus, with metal recycling, there's a lot more reuse going on. Despite the increased use of plastic, there is more recycling going on, and recycled plastics, especially recycled paper, are increasing, although the recycled paper use and consumption has gone up more readily than any sort of recycled plastics, which is just now starting as an economic material base. Focusing on paper and wood consumption, there's been about a 50% increase in worldwide paper consumption over the last decade or more. And this has largely been tied to, probably not so much the last decade, probably the last 20 years, tied to the advent of personal computers, laser printers, inkjet printers, you name it. All of these easier, cheaper access to printing things created a definite increase in the demand for printer paper. That is, I haven't seen data lately, but I believe that's slowing when you look at the amount of electronic correspondence and efforts to go paperless in offices and things like that. But this is still the computer age, and the microcomputer age, PCs and such, has definitely had an impact on our paper consumption. It's estimated that on average, about 700 pounds of paper are consumed each year by the average American, and that represents the consumption and processing of approximately 7 large trees. And the per capita wood consumption, another way to look at it on a volume basis, is approximately 80 cubic feet. And I'll leave it to you to try to construct in your own mind and visualize how much 80 cubic feet is in the room around you, say. Wood is, the positive aspect compared to many of the other materials is that wood is a renewable resource. However, you have to bear in mind that the wood that's consumed for paper and products, especially disposable products especially, it may take decades, 30, 40 years, before a tree grows to the size that it can be harvested and turned. So the turnover rate and the harvesting and production rate of trees is far longer than, say, routine vegetable crops or things that are grown on an annual basis. So if demand is increasing, there's probably, or there is with that, a corresponding need to increase the amount of acreage of trees being harvested to keep up with that demand. And that demand may not be sustainable, especially with concerns over going into marginal lands or lands with sensitive species, plant and animal species, or areas where harvesting on steep slopes may degrade water quality and fish habitat. That's shifted a lot of the demand or the production of timberlands from the United States and Canada to tropical systems where there is less environmental regulation and fairly rapid growth. But the impacts on the environment there can be substantial. So you should review here. You need to know the difference between renewable and non-renewable resources. And the text has an expanded discussion of this, and I would expect you to read that. You need to be able to summarize the U.S. consumption patterns over the last few decades. What are we consuming more of, less of, and why? In the second lecture section, we're going to look at a case study and some of the processes that lead to consideration of whether or not the way we use resources is sustainable or not. Interface Carpets is the business that's highlighted in the textbook. And as the book points out, it was a very successful, probably one of the leading carpet companies in the U.S. to produce carpet tiles. And very profitable. And the book points out that Ray Anderson, the owner, felt that life was good, business was good, until one day when feedback from customers asked the question of what is Interface Carpets doing to make its products environmentally friendly. And apparently that was a seminal moment for Mr. Anderson, and he stopped to think about how they produce carpet tile. It's petroleum-based, synthetics, generates a tremendous amount of waste, and is created largely or almost entirely out of non-renewable resources. So this prompted him to take a hard look at how the company operated and where they could make changes to make sure that their products were more environmentally friendly as well as profitable. Ray Anderson pointed out that they determined that their company just didn't get it. They were following all the rules, labor laws, environmental laws, paid for materials, paid for the disposal of materials, and operating completely within the law as a major industrial operation in Georgia. The problem is that there's more to their operation in the long term than just their daily operations and their immediate profit scheme. And that's what the basis for looking at the environmental and ecological economics of modern industrial practices and consumer product production involves. And I should point out and emphasize the fact that it was consumers giving feedback to the company that triggered the change in Interface Carpet. So if you have any doubts about your ability to make a significant impact on the world via a change within a company, you as a consumer have the ability, either individually or collectively, the ability to give feedback and exercise through consumer feedback to the company or through consumer choice, the ability to influence how businesses operate. This is an excellent example of that. So you'll hear more and more as time goes on, but currently there's a great deal of attention and more being focused on sustainability. And that is, what is this term about? What does it mean to be sustainable? And this concept is fairly simple. If you look the word up in the dictionary, it's just being able to continue doing something, in this case, without degrading the environment. So that you can produce materials or consumer goods without running out of them in order to be able to do that in the future and not preventing future generations from being able to do that. And you'll see this tripartite diagram down here where three areas provide the foundation for what we consider sustainable practices or activities or businesses. There's an environmental component, there's an economic component, and there's an equity or social component. And there has to be balance between these to some degree, and all of them have to be present in order to ensure that the activity or business or product production that they're contributing to is truly sustainable. You can't degrade the environment past a point and continue to do that indefinitely. Likewise, you have to be able to be profitable or to pay your way, both in terms of short-term internal costs, which we'll talk about, as well as being mindful of external costs, and the equity or the social impact, the use of unfair labor practices or exploiting people is not the basis for something that can be carried on in the long term. So sustainable business, sustainable practice, sustainable economic activities are those that literally can go on more or less indefinitely without degrading any of these three areas in the world. So this is a review question that feeds this particular topic. So of the following four items, which is defined as development that meets present needs without preventing future generations from meeting their needs? And hopefully in this case you'll choose A, which is what we've just described. In order to create a sustainable development practice or a business, and to make it possible, you have to understand several items. First, you need to know what good ecosystems are in terms of the goods and services that they provide. And we'll be talking more about ecosystems somewhat later in the course, but we're going to introduce the concept here. Next, there are some newer terms referred to as natural capital and natural interest. And if you leave off the word natural, capital and interest, hopefully you've had some introduction to through finance, personal finance, either in an economics course or somewhere in your everyday life. And then third, it's useful to know how the world operates from the standpoint of economic models, because you'll read and hear tremendous debate and arguments over whether or not doing something for the environment is good for the economy. And underlying that is understanding the economy and economics, how it operates, and what are some of the assumptions that our current economic models employ. These are some of the ideas that we'll introduce in this lecture segment. And finally, you need to have a notion of what are internal and external costs. What's the true cost of something? Another set of terms for this are direct and indirect costs. But in either event, you need to understand the true cost of anything you purchase or consume. So, to start with, ecosystem goods and services. You may have a notion of what an ecosystem is. It's the living, biological environment interacting with the physical environment around it. It could be a forest, it could be a riverside area, it could be a vineyard on a hillside, where the living plant and animal communities are interacting with the hillside, the soils, the underlying rocks, the climate, and so on. So the ecosystem is essentially the natural world around us. There's a human ecosystem, there are urban ecosystems, but it's that interaction between the biological and the physical environments that comprises it. And these ecosystems provide us with goods and services that, for the most part, until you think about them in these words, may not have really realized how much we rely on ecosystems, not just for aesthetic values or for wildlife habitat, but for the value of the services they provide us. Environmental resources are some that we're familiar with. Timber for paper production, for lumber and other wood products. Water. These are ecosystem goods. These are tangible forms of matter that we derive as humans from the environment around us. And they're resources. We value them directly and are typically they're fairly well recognized. There are also ecological processes that constitute ecosystem services. Some examples are the purification of water, nutrient cycling, elemental cycling that makes life possible on this planet. This figure gives you a representation of an environmental economist's effort to try and put a value on many of these ecosystem services. But the textbook points out that even these underestimate the value of something that we take completely for granted and has probably there's no way to put a price on it. And that's that through the process of photosynthesis, green plants, living ecosystems on this planet generate oxygen. Oxygen is essential for life as we know it, for us. How do you put a value, a dollar value, on the air we breathe? Is there any way you can value that? You would have to value life itself, and that's very difficult to do at a planetary total human population scale. And that's an example of an ecosystem service, breathable atmosphere. And it's not even included on this list. Some of the things you will see that might make some sense, easier than others. Climate regulation. We need adequate rainfall or snow in the high country and in the Sierra to produce the water that we use for large-scale agriculture in California. Well, the climate regulation is a physical process affected by plant communities primarily, and those are ecosystem services that have a value of producing not only the water availability, but also the temperature regulation that allows us to produce the food we need for human populations. So there are numerous services here of natural processes that we take completely for granted, that attempting to put a dollar value on at the large scale gives you some sense of the larger economics that is largely overlooked when humans try to value the prospect of leaving a land in natural function as opposed to turning it into some sort of developed use. The value of these other services is critical to consider. And so this comes to the next idea of natural capital versus natural interest. And this is where, again, capital and interest are maybe the more familiar terms for you. So let's take an example from a financial case. A generous relative is feeling that they would like to do something nice for you, and so they give you $1 million one day. Completely unexpected. And if you don't spend it all right away, you might put it in the bank. And $1 million might generate, in this example, $100,000 a year, or about 10% interest. So you decide to spend some money now, and it gives you three different scenarios. If you spend $100,000 a year, you're spending the interest, and the capital is always maintained as a reserve. If you spend less than $100,000, the portion you don't spend adds to the capital, and it grows. And after 8 years, this example, you have more than $1 million. However, if you spend more than the interest, and in this example, say double what the interest is, you can run out of that $1 million within 8 years by spending as little as $200,000 a year without thought to retaining the original capital. So there's your financial example, and I think that, at least other than the dollar amounts, might make sense to you from a personal situation in terms of living off of the interest versus the principal or capital of a financial resource. Now, to translate that into an ecological ecosystem example, the textbook provides you with the case where, suppose you have tuna or any other large ocean-going fish. That provides that population of fish, all of the tuna in that population is the natural capital. And they're breeding, and they're within their ability to add to their numbers each year. So the natural interest would be the cumulative birth rate, or based on the cumulative birth rate that we talked about in the population lecture, and you would have population growth. So if you harvest the fish for a food source, say, as long as you only take as many fish as are born and survive each year, the original population of the fish, the tuna, is maintained. If you take less than are born or added to the population each year, then that population may grow depending on availability of its food sources or predation or other controls on its population. However, and this is the case currently with many major fish species in the ocean, if we collectively harvest, and this could be different countries each taking their perceived portion of the tuna, if we harvest in aggregate or in total more tuna than are produced each year, then eventually the population can be diminished to the point where it crashes, and you could actually have an extinction event. So again, there's a strong linkage between our financial example and the natural systems example that you can find in ecological systems. Both are trying to portray the difference between the capital, say the starting population or the starting financial balance, and the amount of money added or individuals added to the population, and then how do we use either resource, either at its annual production rate or greater or less than. So then we come to the notion of economics itself and economic analysis. You're probably used to thinking of economics as being concerned with job growth, the calculation of the amount of exports, imports, financial reserves, and so on. These are economic data that we're commonly exposed to through the media. But economics is more than that. It is a total look at a system and may include things like the future workforce. Examples are the graduation rates of in science, engineering, mathematics, STEM, the male versus female in terms of who the future workforce is going to be. So in general, economics is a social science, and it deals with how scarce resources are allocated. And to the extent that there are 7 billion people on the earth, most resources have the potential to become scarce fairly readily. But as we noted, it considers many other areas than just the money and the finances. Many of the resources and ecosystem services that we depend on come from the environment, and as such would need to be valued and analyzed much the same as any cost or financial resource would. This leads us to the notion of economic modeling. And traditional economics take a fairly non-scientific and simplistic view, but they keep just primarily to the resources that are used, their extraction, whether they be energy or natural resources and materials. They'll go through some sort of a production process. They'll be turned into a usable form. They'll be consumed. Those values, the profit derived from their sale and use, and the benefits derived from that will be calculated internally within society. And then there's a waste component of the material after the material has been used, whether it be waste rock, or whether it be wood waste from processing lumber or paper, and so on. But there's and the disposal of the final product itself. So this is a linear system where you take a resource, you use it, you derive value from it, and then you dispose of it. Mainstream economics, like most models, have a series of assumptions with them. And these are going to be in contrast then with the ecosystems of the earth and the natural systems that exist beyond human society, but are closely related. Most economic models currently and historically used take that linear line of thinking in terms of extraction, use, derive benefits, and then dispose waste of. They assume, and I've heard this repeatedly, that the resources and the human resources are infinite and or easily substitutable. We assume that most economic growth is patterned on continued growth. This goes back to the last lecture where I asked the question, if you have a small town of 100,000 people, like Chico, can it grow indefinitely? Well, most economic growth envisioned for a town like that would assume or desire that it can grow indefinitely. The notion of steady state economics is not well established in most business models and economic models that you'll see in everyday society. And so the resources, the human resources, the ability to grow indefinitely is assumed to be, can go on indefinitely. And the interesting thing is that the waste that's released from most production and resource-based systems assume that you can just simply throw away materials and that they have no consequence and no cost once they're disposed of. So there is a throwaway, there is an away that things go to and don't enter back into your economic analysis. This contrast, or these ideas contrast with the real systems that operate and underlie those ecosystems, goods, and services. First, nature operates in a cyclical fashion. Think of the water cycle. Water reaches the atmosphere, returns as rain, moves through systems, evaporates, and then regenerates the precipitation system. Most elements operate in a similar cyclical fashion. And resources, especially energy resources that are most commonly used ones, are not infinite. And it's not that easy necessarily, at least in the current time, to develop substitutes, although we're making quite a bit of progress. It's not a simple process of well, if we can't use this or we run out of oil, we'll find something else. Well, there are things like jet fuel, for example, that we're just now starting to find alternatives to biofuel, or biofuel alternatives, but we're still a fuel-based aircraft propulsion system. We don't have other drive systems, and so there are very real limits to how far we can go with air travel, for example, in terms of finding substitute resources. Most ecosystems are typically already at a steady state, meaning that they take in what they need, they release some materials through to other parts of the landscape or the watersheds around them, but they are not necessarily continually growing. An example would be a forest. It will grow to a mature state. There can be a natural lightning or other wildfire situation that will remove the forest, seeds will resprout, and the forest will return. And there is no continual growth, no way that long-term growth can go on either indefinitely or for very, very long period of times. There will be some sort of a steady state, a dynamic steady state, where systems will change, reset, and start over again. And ultimately, when waste material is generated, there is no true away where waste goes to. Things that you put in a landfill, certain chemicals will come back to the environment that will affect humans surrounding them. Waste materials that we throw away can generate gases that can contribute to climate change. So there are no real places or situations to where you can truly throw away materials and waste materials and not have a long-term cost or consequence to. So if you think of an economic model, unlike the linear one we showed you earlier, that has more of an environmental or ecological basis for it, these are going to be ideally closed-loop systems. Resources, especially energy resources, are going to be renewable and readily renewable on a short time frame. Resource extraction can be minimized by reusing materials and coming up with natural alternatives. Materials that are used internally and the value that's derived from them will feed back to investment in the perpetuation of those energy or resources that are extracted. And there's a much greater emphasis on waste management, waste decomposition, composting, reinvestment of the waste material, and finding alternative uses for it, so that only the barest minimum of those wastes that are very poorly reused or recycled are truly generated and have to be isolated from the environment. It's very important that you, through this course, develop an awareness of the importance of the time frame over which we think, operate, consume, and invest or put value back into the world around us. The long-term impact of the things we choose today have tremendous implications for human society and the environment around us. We have to think of closed-loop systems that are based dominantly, maybe not entirely, but dominantly on renewable resources. And we have to be a lot more efficient in the resources we use. The next time you go in to a public restroom or any place with a paper towel dispenser, as you go to use the towel to grab a paper towel, and I commonly see people grabbing 2, 3, 4 to wipe their hands. What if you were in a situation where you had one package of paper towels that had to last you for a very long period of time? How could you get the most use out of that rather than a more wasteful use of using more than you absolutely need? Likewise, if you have a dripping faucet, if you leave the water running while you're brushing your teeth, think of yourself as being in an arid environment where water is precious and you have to carry it say from the water source to where you use it. So you want to minimize your waste and you want to be as efficient as possible. And I truly believe that if you start to think in these terms, it becomes second nature. It doesn't change how you operate, it becomes how you operate, and you become far less wasteful than we are most of the time when we don't stop to think about what we consume. And this leads to a reduction in waste generation, less waste going to landfill, better recycling, better reuse, and simply a reduction in the amount of materials that we consume. To contrast the two, we talked about environmental economics and then ecological economics, and there are some philosophical and ideological differences between the two. An environmental economist believes that we can use the tools of modern economics to solve the problems we face in the environment and still keep on growing in the traditional unlimited growth models. Not business as usual, but still a growth-based economy with no end in sight. In reality, there are ultimate limits to growth. We're very close to, or we must be approaching, the limits globally to how many people we can support in anything approaching a reasonable standard of living. So we're forced to think about more of a steady state, non-growth economic system. And that's where ecological economics comes in. It's that you can only do so much with technology, with clever practices, that the growth is, there are economic growth limits. And we must change the way we do things and find happiness and satisfaction with a standard of living that's based not on a continued growth model, that we can find balance between the materials we desire and consume and the value we place on those and the costs we're willing to bear, in balance with a functioning set of ecosystem resources and services. So there's a significant difference between environmental economics and ecological economics in terms of how they view primarily the notion of growth in the long term. One of the final areas we mentioned earlier is that the current economics we work with doesn't take into account all the potential costs associated with a given product, material, or service. So, some review questions. The traditional economics tend to discount the future value of goods. The result is that ecosystem services become devalued, short-term benefits outweigh long-term benefits, ecosystem value services become overvalued, or D, none of the above answers are correct. So which of these do you believe ties to this notion of the fact that we don't, in modern traditional economics, don't tend to account for the future value of goods? So take a look at that and then review that section in the text. So internal, external, and true costs, direct and indirect costs. If you look at this notion as a total true cost, the book uses the term internal costs and external costs. You can also use the term, direct and indirect. An internal or direct cost for, say, paper, that the books you'll be buying if you're taking classes this fall, would consist of the buildings that were used to process the paper, the electricity that ran the equipment to process wood pulp into paper products, the trees, the labor both in the field and in the factory, the equipment, the transportation, the fuel costs. All of that goes into the price per piece of paper you may be consuming. Those are the internal costs. That's what goes into the cost you pay at the store. Now, there are also external costs or indirect costs that you don't see directly as a consumer. These would involve things like soil erosion that might occur with harvesting on oversteepened lands, application of pesticides or fertilizers to forest lands to try and get more tree growth that then impact the water quality downstream and populations that rely on those water and treatment systems. The soil erosion itself can be the loss of productive soils. The air pollution and pulp and paper plants are some of the dirtiest, at least historically, of any of the air quality problems we face. They are a typical source to make white paper. The bleaching process leads to the formation of dioxin, which is in close competition with plutonium as being one of the most toxic substances humans have enhanced or either created or enhanced in the environment. So the air pollution costs are very significant, and those can lead to health problems. So the health problems, the deforestation, the water pollution, the price for those is passed on to society, and it's passed on to you as a taxpayer. So if you think about it, you're paying considerably more for a piece of paper than just the price that is charged for that ream or that case of paper or the book that is used. The price is spread, though, through taxes, through the cost of other materials, and especially if you're concerned about paying too much taxes and too much government, a lot of those taxes go to things that are dealing with these other external costs of wood and pulp production for production of paper, which is one of the primary uses of forest systems. So you can value these to some degree, but we know that there is external cost associated with these problems that come from, or typically associated with, the production of paper. So the true cost is not being paid for by the consumer, it's being passed on to the taxpayer, regardless of whether you use much paper or not. So if you think about it, the businesses that produce the goods and or services and the individuals who purchase things will impact the environment regularly with the economic decisions they make and the decisions that you make. And it's being conscious of that and being, again, conscious of waste, consuming only what you need, not so much of all that you want, that you can attempt to reduce the impact of these kind of choices. The way we think about increasingly now the total cost and the total impact of all these decisions is known as the ecological footprint. And we'll be talking about this at several different points through the course. In this, our third and final section of this lecture, we'll examine a way of quantifying our impact through resource consumption, and that is embodied in the notion of the ecological footprint. The ecological footprint is based on a number of different factors, and some of them can be used to compare a fossil fuel-based society, such as our current one, or a greater reliance on renewable energy in the future. By definition, our ecological footprint is based on the land needed to provide the resources for and assimilate the waste of a person or a population. That includes both raw materials used in the city or wherever the calculation is done for. It can involve the physical footprint of the city and how it affects water runoff or air pollution coming off, and some of the waste that's assimilated by areas outside the city, such as at a landfill or other waste dumping area. The total footprint is that ecological footprint of the people living in that particular area. The footprint will vary for different countries based on their population size and their per capita impact. So envision people living in a remote village with no electricity, minimal running water, very limited housing structures, and their impact on resources, both with the support of their lifestyle and the waste they produce versus modern United States and, say, California society and your own ecological impact. The graphic shown here considers that for a population of U.S. population of about 300 million, it's estimated that that requires about 2 billion acres of land to provide the resources and assimilate the waste of our population. This equates to approximately 24 acres per person, and thus the U.S. overall is consuming approximately 7.2 billion acres total, compared with the 2 billion acre landmass of the United States itself. So China's population, in contrast, is 1.3 billion. The area is roughly of China is roughly similar to the United States of 2 billion people, and the footprint of that much greater population for the same landmass is about 2 acres per person. So China uses approximately 2.6 billion acres to support its population. And if you've done an ecological footprint calculation, you will do one again in this class, they'll give you an estimate of the number of planet Earth equivalents required if everybody on Earth had a footprint like the United States does. We would need over 6 Earths for the human population on this planet to live as we do in the United States. Conversely, if everybody on Earth had a footprint equivalent to the one in China, we would have land and resources to spare. However, that's changing with the rapid economic development that's going on in China. So fairly soon they will have a resource consumption base that will at least be equal to the current space of our planet, if not greater, depending on where their growth takes them. In order to calculate or estimate the size of an ecological footprint for a given place or population, researchers often use what's called the IPAT equation. And this equation is a simple quantification of the effects of the population size, their level of affluence, and technology, and how much those individually will impact an individual or population and its footprint on the environment. As population or affluence increases, what happens to the technology? It can either be an additive effect, along with the impacts of the other two factors, or it can be reduce the impact if the appropriate technologies are used, such as using to more innovative alternative energy systems. So let's return to our case study of interface carpets and examine how they reduced their environmental impact and achieved a more sustainable business practice. They looked at two different ways to do that. First, they examined the product line they had and tried to find ways to reduce its impact. They used biomimicry, which, if you'll recall, is the practice of imitating a natural design or a natural pattern in the design of products. Interface Carpet developed what they refer to as tactiles. Remember, they produce carpet tiles technology, and they set up their carpet glue based on how gecko lizards will cling to walls. So essentially they were able to reduce the amount of toxic petroleum-based glues to a more of a physical contact-based adhesive. They did more than that, just change their product line though. They also examined their overall operations, what's called the life cycle analysis, in their overall business model. They took an inventory of their energy and material inputs and evaluated the environmental impact of the product, in this case carpet tile lines that they produced. And in response to a need to change, they adopted what they refer to as a cradle-to-cradle system. And this management system allowed them to reduce their energy inputs by about 43% per unit of production, and they relied much more heavily on recycled and bio-based ingredients for about 40% of its raw materials. So this further reduced their energy and resource impact in the production of their product. But that's not all. They went from a purely product-oriented economy and as a product-oriented producer to become more of a service economy by changing the way that they focused on the consumer and the way they provided their product and services to the consumer. Their original model as a product economy took predominantly petroleum as the main raw material for their carpet products. In the factory they produced carpet squares and generated a substantial amount, billions of pounds of waste annually. Consumers would purchase the carpet, they'd use and care for the carpet themselves, and then after a period of time or wanting to remodel, consumers would discard the carpets, and that would be essentially a linear model of sending it off to the landfill. In reinventing their product line and their approach to the business, they took into account the service and a long-term interaction with their customers. They produced the carpet tiles containing 100% recycled content. Instead of selling the tiles, they leased the tile or the carpet tiles to the consumer, and they provide service, upkeep, maintenance, repair, replacement of the tiles. And if the customer wants a complete changeover, say during a remodel, they'll come in and replace all the carpet sections and essentially redo them. The innovative part of this is they take the materials back, the carpet squares back, and fully recycle them and keep them out of the landfill and put them back into the carpet factory and repeat the process. It's noted that they hope to even go in and mine landfills for discarded carpet if that can be recycled back into their processes and produce more new materials. So this is a whole different way of interacting with the customer, of servicing the customer's needs, and producing essentially no waste in the process of providing a product to the consumers. This has been quite a transformation for Mr. Anderson, who founded Interface Carpets. And the quote here, I think, gives you a sense of realizing that a change was needed. The book talks about the search it took him to figure out how to even approach this problem and what to do about it. And they realized but something had to be done. I think he recognized with insight from others that the practices they had were not sustainable, and that with the cost of resources and the indirect cost of the waste materials they were producing, that it was important to try an alternative model, and it turns out they've been very successful. This provides an excellent example of how businesses can reinvent themselves to achieve a more sustainable business model and environmental model for their business without losing customers and essentially with creating new market opportunities. This concludes the third part of our lecture. You should complete the lecture quiz following your review of this material.